What impact do cache control headers have on CDN optimization? Imagine trying to get a package delivered quickly across the city. The faster it arrives, the happier you are. That's what cache control headers do for websites and their visitors. They tell browsers and content delivery networks how to handle the content they fetch. These headers are like instructions that decide whether content gets stored locally or fetched fresh every time. When set correctly, they help websites load faster and reduce the strain on servers. Cache control headers specify rules for caching web responses. They tell browsers and CDNs how long to keep content before checking if it has changed. For example, the max age directive sets the number of seconds content can stay fresh in cache. If you set max age to 1 year for images or style sheets, the CDN can serve those files without asking the origin server again. This means quicker load times for users because the data is served from a nearby server. Another important directive is smaxage, which controls how long shared caches like CDNs keep content. It's similar to maxage but applies specifically to shared caches. Using smaxage allows website owners to fine-tune how long content stays at the edge servers. This helps balance freshness and speed. The public and private directives decide who can cache the content. Public means the content can be stored in shared caches like CDNs, while private restricts caching to the user's browser only. This is useful for sensitive data or user-specific pages. No cache and must validate are directives that tell caches to check with the origin server before serving content. This is helpful for dynamic pages or data that updates often. It ensures users see the latest version, even if the cache has a stored copy. No store, on the other hand, prevents caching altogether. It's used for sensitive or rapidly changing information that should never be stored. Properly configuring cache control headers improves CDN performance in several ways. First, it speeds up load times by serving cached content from locations close to users. This reduces the time it takes for data to travel across the internet. Second, it cuts down on the number of requests sent to the origin server, lowering server load and bandwidth costs. When content is cached longer, fewer requests are needed, saving resources. It also helps keep content fresh. Using shorter max age or must validate directives makes sure users see the latest updates. For static assets like images or scripts that rarely change, setting long max age values with the immutable directive means they can be cached for a long time without revalidation. This boosts performance without risking outdated content. Another benefit is increasing cache hit ratios. When content is cached effectively, the chances that a user's request hits the cache instead of the origin server go up. This makes delivery faster and more efficient. Faster sites improve user experience and can even boost search engine rankings. Website owners can also use cache-busting techniques like versioned file names. When content updates, changing the file name forces the CDN and browsers to fetch the new version, avoiding stale data. For dynamic content, setting no cache or must validate ensures users always get the latest information. Differentiating caching policies between public and private content helps maintain security and privacy while still optimizing performance. Sensitive data should never be cached in shared caches, but static assets like images or style sheets can be cached for long periods. In summary, cache control headers are vital tools for guiding how CDNs cache and serve content. Properly setting these headers helps websites load faster, reduces server load, cuts costs, and keeps content fresh. When used wisely, they make the internet faster and more reliable for everyone. This all ties into the bigger picture of internet infrastructure, where network routing and bandwidth management work together to deliver content quickly and smoothly worldwide.